So as you can see here, we use a board detection algorithm for generating an Aruko marker, which is based on a Aruko OpenCV library. The marker images are generated using a draw marker function. So here, we set this to a 7 by 7 by 100, which is the size of the markers, and generated 100 image targets. So so after running this code, we were able to generate 100 Aruko markers. So after generating the markers are uploaded into a database. So as you can see here, this is the database for our Aruko markers. So here you can see it has 100 targets in our device database named AR1 database. And after opening the database, we can see all of the image targets that has been uploaded. So as you can see here, it has a rating of a 4 stars and 3 stars, meaning that it is augmentable on how the device can easily capture the AR images.
Uh, okay, so for the assets or the 3D models, uh, we use Blender Animation, which is a free and open source 3D computer graphics software. It's a toolset used for creating animated films, visual effects, art, 3D printed models, and as well as interactive 3D applications in video games. Now, why did we use Blender? Um, because Blender uh, it supports the entirety of 3D pipeline, which is modeling, rigging, animations, simulations, rendering, compositing, motion tracking, as well as video editing and game creation. Now, after creating these 3D models, we exported it as a .blend file that we'll be able to use in Unity. As you can see, here are samples of our 3D models. And
After generating the Aruko markers and creating the 3D models in the Blender application, we've used the Unity application to connect everything from the Aruko marker database, which is located here, up to the 3D models that we have imported or created in the Blender application. So we've also imported the packages from the Vuforia and some texture for the game objects that we used in the uh, AR application.
So now I'm going to demonstrate how our AR application works. So let's go to the application. The application is named ARALS. So let's open it. So as you can see, here we have two buttons, start and quit. So let's press start. So after pressing start, the application will go into a capturing mode wherein it will use the camera to capture AR markers. So as you can see from the screen, we have our previous and exit buttons and the module that came from the ALS. So so the application has already detected the module that is now playing. So So if we move the module, we can now see the module correctly. So as you can see, the module is moving. It has a moving function that is corresponding to the module. So beside it, it has a description on what the module is trying to do based on the module that was given to us. So this is our sample. So let's try our next sample. So let's try to detect this as well. So as you can see, the AR marker has been detected. It has now overlay a 3D model. So our application has also audio, but you will not be able to hear it. So right now we have a function that if we press on the marker, it would start its moving function. So let's try that. So as you can, I have now tapped the markers. So now, as you can see, it is now moving. So if I lift my finger, it would stop moving, and if I try to press on the marker, it would start moving. So there. So after that, we are now going to exit. So let's just press the exit button, and there it is. That's our AR application. Thank you and goodbye.